system, we have four main processes, which are filling, capping, labeling and transportation. The first process in this system is filling. When the push button is pressed, the cylinder actuated from S1 to S2. After it actuated to S2, then 5-12 valve solenoid at YT will triggered. Then cylinder in S3 will actuated to S4. After that, it will transfer to the next process.
Cylinder S4 in filling system will trigger the solenoid valve Y5 and will flow to the cylinder S5 and to the cylinder X6 for transport the bottle or capping process. And then cylinder X6 will trigger Y7. After that, cylinder S7 will extend and do the capping process. Next, cylinder S8 continue to the next process, which is labeling process. As you can see, this is the electric circuit for capping process. Cylinder S8 from capping process will trigger the solenoid valve Y9 and will flow to the cylinder S9 and will extend to the S10 for transport the bottle for labeling. And then S10 will trigger to the solenoid valve for Y11. After that, cylinder 11 will extend to S12 to do the labeling process. Next, S30 will continue to the next process. And this is the electric circuit for labeling process. After labeling process, the bottle will push to the cylinder S30 and will extract to the S40. And then the bottle will push to the next process, which is packaging process. As you can see, this is the electric circuit for the process after labeling process. Y2 and Y4 in filling system will return after S4 actuated. Y6 and Y8 in capping system will return after X8 actuated. Y10 and Y12 in labeling system will return after S12 actuated. This is how our project design. Start with the filling system and then go to the capping system and then will flow to the labeling system, and the last one will be to the packaging process, which is transporting system. And as you can see below pneumatic circuit, there is a electric circuit, and it is how our electric circuit flow. That's all from us. Thank you.
Next, for the design calculation, the cylinder diameter D1 equal to 100 cm and the piston rod diameter D2 is equal to 2 cm. The pressure is 10 bar. The efficiency factor H is equal to 0.45. Then, First one, the effective area for advanced stroke is A equal to D1 square times pi over 4. And the answer is 78.5 cm square. The force for advanced stroke is F equal to pressure times area times efficiency factor. And the answer is 353.25 Newton. Next, for the retracting stroke, the area is A equal to D1 square times pi over 4 minus D2 square times pi over 4. And the answer is 78.5 cm square. And last, the force for retract stroke is F equal to pressure times area times efficiency factor, and the answer is 339.3 Newton. And last, the cylinder air consumption, we use the formula of A1 plus A2 times S, which is stroke length, and N cycles times atmospheric pressure plus operating pressure over atmospheric pressure times 1 over 1000. After we calculate, the answer is 41.94 cm cubic per second.